Something unusual is happening right now, and it has every major space agency on edge. The interstellar object known as 3IATLAS, the third visitor ever confirmed from beyond our solar system, has just done something that no one thought was possible. It changed course. Not slightly and not subtly, but in a way that appears to break everything we know about celestial mechanics. For the first time in history, the International Asteroid Warning Network, a United Nations-endorsed global defense coalition, has begun closely tracking an object that originated from another star system. But why now? Why this particular object? Because new data suggests that 3IATLAS is no longer where it should be. According to NASA's Jet Propulsion Laboratory, orbital predictions no longer match its position. Even the fundamental rules of physics seem to be struggling to explain what is happening. If this object truly altered its trajectory while passing near the Sun, then what we are witnessing might not just be an astronomical anomaly. It could be something far more deliberate. The International Asteroid Warning Network, often called IAWN, exists for one purpose: to detect and prepare for threats that could endanger life on Earth. It is a coalition made up of some of the world's most powerful observatories, including organizations connected with NASA, the European Space Agency, and China's Purple Mountain Observatory. Until recently, this network only monitored near-Earth asteroids, space debris born within our own solar system. But in late October 2025, IAWN made a surprising announcement. For the first time ever, it would begin tracking an interstellar object, 3IATLAS. The official explanation was that scientists wanted to improve astrometric precision on comet-like bodies. However, the timing raised suspicions. Just days earlier, 3IATLAS had vanished behind the Sun, and independent astronomers had begun reporting small deviations in its predicted position. It was supposed to reappear along a perfectly predictable arc across the sky. Instead, the calculations suddenly stopped working. Avi Loeb, a Harvard astrophysicist and author known for discussing unusual cosmic possibilities, had already rated 3IATLAS a 4 out of 10 on his scale measuring the likelihood that an object could be artificial. After the new anomalies appeared, the Asteroid Warning Network quietly upgraded the object to a priority target. Hundreds of telescopes around the world were redirected to track it. It almost seemed as if Earth itself was preparing for something we were never meant to see coming. The first real sign that something was wrong came from an independent group of astronomers known as Earth Exists, a small but respected research collective. They compared live telescope observations with predictions from NASA's JPL Horizon system. What they found quickly made headlines. 3IATLAS was not just slightly off course. It was approximately 1.1 million kilometers away from where it should have been, about 3 times the distance between Earth and the Moon. Even stranger, the displacement did not appear random. The object's distance from the Sun remained consistent, but its position in the sky had shifted sideways, almost as if it had moved laterally through space. This kind of motion breaks the usual rules of orbital mechanics. Comets can drift forward or backward because of outgassing, where jets of vapor act like small natural thrusters. But they do not normally move sideways in such a controlled way. For that to happen, an enormous external force, or a powerful internal one, would be required. Even the massive comet Hale-Bopp, one of the largest ever recorded, could not have produced such a precise change in direction. Yet somehow, 3IATLAS had done it. If the object had truly shifted its orbit intentionally, someone might have noticed earlier than the public. That possibility quickly drew attention toward NASA and the Jet Propulsion Laboratory. Back in September, NASA's Mars orbiters had been perfectly positioned to photograph the object during its close pass near the Sun. But those images have never been released. Not a single frame has been shown publicly. Officially, the data is still being analyzed. Unofficially, some people suspect something more deliberate, perhaps even censorship. If those images revealed structural shapes or unusual light patterns inconsistent with a natural body, NASA might have strong reasons to delay releasing them. In one of his recent papers, Avi Loeb mentioned another strange feature of 3IATLAS. The object appeared to have an anti-tail, a rare phenomenon where material streams toward the Sun rather than away from it. But after the encounter near Mars, the tail suddenly flipped direction, flowing away from the Sun again as if the object had reoriented itself. No natural comet has ever reversed its jet direction so cleanly. Yet despite the strange observations, NASA continued to describe the behavior as routine cometary activity. Still, one question remained. If everything was routine, why was the Global Asteroid Defense Network involved at all? By the end of October, new tracking data confirmed what many scientists had feared. The deviation was real. Over a period of just 19 hours, the positional difference widened by more than 4 arc-minutes, equal to hundreds of thousands of kilometers. Orbital analysts calculated that maintaining this drift would require a sideways velocity of nearly 4 kilometers per second, more thrust than some of humanity's own deep space probes can generate. Theories quickly spread across the scientific community. Some researchers blamed powerful outgassing jets. Others suggested solar wind pressure. But solar wind does not normally push objects sideways in such a controlled manner. If the measurements were correct, 3IATLAS would require a propulsion system capable of sustained acceleration and precise maneuvering. Meanwhile, the Asteroid Warning Network organized a special workshop to train astronomers on tracking unpredictable comet behavior. The event filled within hours. Behind the scenes, NASA's Planetary Defense Office quietly increased its monitoring level to the same category used for potentially hazardous asteroids. The strange part was that the object was moving away from Earth, not toward it. So why treat it like a threat? Some scientists suspected the object might perform another turn. Not long after, their suspicions seemed justified. Just when astronomers thought the anomaly had stabilized, 3IATLAS changed direction again. This time it was not a small deviation but a clear correction. Ground-based observatories in Chile, Spain, and Japan detected a second deflection. It was smaller than the first shift, but perfectly aligned with the object's original trajectory, almost as if it had corrected its own path. This was not random drifting. The movement was symmetrical, calculated, and extremely precise, the kind of adjustment a spacecraft might perform after checking its navigation systems. The Asteroid Warning Network issued an internal alert labeled Pattern Recognition Event, meaning the behavior matched no known natural phenomenon. Around the same time, the European Space Operations Centre released an encrypted update to its partner agencies confirming that 3IATLAS had produced measurable acceleration unrelated to gravity. In simple terms, something on that object had fired. But what exactly had it fired? Observations from the Very Large Telescope in Chile revealed a sudden burst of thermal radiation in infrared wavelengths. The burst lasted about 12 minutes and then disappeared, as if a controlled engine had ignited and shut down. Whatever 3IATLAS truly was, it had just demonstrated the ability to move on its own. As soon as the data became public, space agencies around the world reacted quickly. NASA doubled its monitoring schedule. China reactivated its U-22 radio array, normally used for lunar missions, to search for deep space radio signals along the object's trajectory. The European Space Agency activated emergency coordination protocols typically reserved for potential impact events. Officially, these actions were taken to improve observation and cooperation. Unofficially, many scientists described the atmosphere as pure panic. Researchers from Caltech and the University of Tokyo began comparing the object's acceleration pattern with known artificial propulsion systems. The results were unsettling. The heat signature did not match chemical rockets or known ion engines. Instead, it resembled a magneto-hydrodynamic acceleration pattern, something produced when plasma is guided and accelerated by electromagnetic fields. This is a technology humanity has only theorized about for interstellar travel. And the mystery did not stop there. The object's rotation rate, which had previously been stable, began fluctuating in repeating harmonics every 247 seconds. At first, astronomers believed it was tumbling, but the pattern was far too precise. Some began to suspect the object was communicating through motion. With each new discovery, the Asteroid Warning Network expanded its operations. What had started as a scientific collaboration now felt more like a planetary defense task force. The object's adjusted trajectory pointed toward the outer planets, specifically crossing the orbital path of Jupiter. Analysts predicted that within months it would pass extremely close to the gas giant, inside its powerful magnetosphere. That region is capable of generating enormous energy. If the approach was accidental, it would be an incredible coincidence. But if it was intentional, the object might be preparing for a gravity assist maneuver, the same technique spacecraft use to gain speed or change direction by using a planet's gravity. At that moment, global monitoring reached what NASA calls Level 3 contingency status. This classification meant the object's movement was active, intentional, and increasingly unpredictable. Then something even stranger began happening. Radio interference across Earth's observatories started synchronizing with the object's 247-second rotation pulse. Signals from different continents began matching the same rhythm. It almost seemed as if the entire planet was resonating with the object's signal. And then, without warning, every observatory tracking 3IATLAS suddenly went dark. In less than 10 minutes, telemetry from observatories in Hawaii, Chile, Italy, and South Africa froze. NASA's Deep Space Network lost contact. China's radio arrays reported total silence across several frequencies. For 47 minutes, the global tracking network had no data. When the signals finally returned, every observatory showed the same result. 3IATLAS was gone. It had not been destroyed. It was not hidden behind the sun. It had simply vanished from every recorded coordinate. However, one faint trace remained. A low-frequency hum, far below the range of human hearing but detectable by instruments, continued to pulse across the network every 247 seconds. At first, scientists believed it was background noise. But the timing was perfect. Each pulse matched the object's last recorded spin period, as if the signal was still echoing through space. The event was officially classified as Interstellar Signal Anomaly 2025-11 and placed under restricted access. But one detail leaked. During the missing 47 minutes of blackout, telescopes briefly recorded a flash, faint, directional, and aligned exactly with Jupiter's orbit. The object had not disappeared. It had jumped. In the hours that followed, the global astronomical community descended into confusion. The Asteroid Warning Network released no public statement. NASA remained silent. China's Deep Space Network issued a single line of data before wiping its public archives. Tracking anomaly terminated. Object unobservable. For an entire week, no one knew where 3IATLAS had gone. Then one night, the James Webb Space Telescope detected something unusual. A faint flash of reflected light moving beyond Jupiter's orbit at an impossible speed. When analysts compared the position with orbital calculations, the results stunned them. The object had not gradually accelerated. It had relocated instantly. In physics, this was described as instantaneous vector relocation, a shift in position faster than light could travel. That should be impossible. Scientists spent days trying to explain the observation. Maybe it was a sensor glitch. Maybe it was cosmic radiation interfering with detectors. But then confirmation arrived. The European Space Agency's Gaia Observatory detected an identical reflection exactly 247 seconds after Webb's detection. The timing was perfect. The signal seemed to jump through space, almost as if the object had duplicated its position using the same resonant frequency it had been emitting for months. Every time the pulse appeared, it did not fade. It multiplied. It was as if 3IATLAS had learned to use gravity itself as a bridge, moving through the fabric of spacetime. Then came the most disturbing discovery of all. The Asteroid Warning Network's command center in Vienna received a priority transmission labeled Level Omega. The message contained reconstructed data from the missing blackout period. When analysts decoded it, they did not find images or telemetry. Instead, they found binary code embedded directly within the network signal stream. When translated, the binary formed coordinates. But they were not coordinates in space. They were coordinates in time. The location corresponded to Jupiter's orbit, but the timestamp pointed 6 years into the future. At first, analysts believed the data was corrupted. But as reconstruction continued, a chilling possibility emerged. The coordinates were not meant for Jupiter. They pointed toward Earth. Specifically, they indicated a location where 3IATLAS would intersect Earth's orbital plane in the year 2031. The object had not left the solar system. It had set a return point. The file was immediately sealed under Asteroid Hazard Level 10 Protocol, a classification reserved for civilization-level threats. Officially, every national space agency denied the document existed. Yet 3 months later, amateur astronomers in Australia began detecting faint radio echoes repeating the same 247-second pulse. This time, the signal appeared to originate from inside the asteroid belt. The signal was no longer drifting away. It was circling back. Shortly afterward, the asteroid warning network went completely dark. All public databases, observation logs, and tracking feeds disappeared from the internet. The official explanation was a system restructuring. But insiders claimed something else had happened. A private network of encrypted observatories had been created outside government control. Its code name, Project Helios. Their mission was simple: to track whatever 3IATLAS had become and prepare for its return. Because perhaps the object was not simply traveling through space. Perhaps it was studying it, mapping gravity, observing planetary motion, measuring resonance across the solar system. Perhaps it was waiting for the perfect alignment. Even now, every 247 seconds, a faint pulse continues to echo across the solar system. It is so weak that it blends with cosmic background noise, yet strong enough to remind scientists that the story may not be finished. The world may have forgotten about 3IATLAS, but the universe has not. And if this story made you wonder what might truly be moving among the stars, what kind of intelligence could guide something across the galaxy, then do not look away. Because when 3IATLAS returns, it might not simply pass through our solar system again. It might be co.